Hello, everyone, and thank you for joining us today. My name is Jim Armstrong, and I'll be presenting today's content. I'm a product marketing manager here at Snyk, and want to share with you a bit about what Snyk Container does, and specifically talk about dev-first container security and how that's a little bit different from maybe what people have considered with other bits of container security. Container security is a broad topic. There's loads of things that go in there because containers obviously are this sort of weird middle ground between a developer focused bit of packaging and an operator focused bit of how applications actually run. So there's lots of things you could talk about with container security. What we're going to focus on today is a lot of the developer aspects. What is it that an application team is actually concerned with or needs to be concerned with, and how Snyk helps them handle dealing with those issues when it comes to containers. I would encourage you to ask questions along the way. There's a Q&A panel available in GoToWebinar, and you can type your questions in there as we go, and I'll pause at various places to look and see if there's any questions and answer them at that time. Today's session is also being recorded, so if you want to share this later or come back later to recap on some things, you can definitely do that as well. And you can always reach me if you have other questions as well. You can reach me via Twitter, or we have Snyk community and other places as well. So I'm more than happy to chat with folks with any types of questions that you might have. All right, so let's dive in. So we're going to do a little bit of level set on, just for folks that may not know who Snyk is. We'll do a quick recap on that, and then we'll get into the container specific aspects of Snyk. And really kind of focusing on what some of the unique issues are with containers and container security, and specifically the issues that a developer and application team might have to deal with there, and how Snyk can help with those issues. We'll do lots of demos through this as well, so it's not all slides. You'll see the Snyk product in action in several places, several different integration points that you might want to be testing containers, and you might want your developers and application teams to be looking at those security results and dealing with them. And so we'll take a look at those along the way as well. So a quick background on Snyk. Today's applications obviously are more than just the code that your teams write. That's obviously probably the most critical piece. That's the piece that really differentiates your applications from other folks. But those applications bring in loads of other things with them that have definite security implications. So Snyk started with the open source dependency scanning, software composition analysis, and Snyk open source is there to help. What we find there is, your code tends to be just a tiny bit of the actual application. The dependencies and libraries and other things that get brought in make up the bulk of the actual final code. And there's loads of vulnerabilities that can surface in those things. And since you don't have direct control of them, it can be hard to maintain those. And a dependency might have a dependency on something else, which might have a dependency on something else. And so things become more and more complicated as you traverse all these different sort of interdependencies and transitive dependencies. So Snyk open source is designed to help folks uncover all those interdependencies and find vulnerabilities in there in the code that's maintained by somebody else, the open source libraries and frameworks that you might be bringing in to help your applications and to, quite frankly, create applications faster. More and more, those applications are getting packaged up in containers. That's what we're going to focus on today. In containers, obviously, again, there's loads of things you could talk about under the umbrella of container security. What we're going to focus on is what's inside that container. Now, the code and the open source dependencies are an obvious part of that, but there's loads of other bits that are in containers as well. Again, just like with the open source, there are often bits that you don't have any direct control over. Most folks that are probably listening here are not Linux maintainers, and so you don't have the ability to go and just fix those issues by changing the code itself. You are relying on somebody else to fix them, but you also need to discover those things. And it's a challenge for developers to do that because they're not experts at any of that. And then, of course, the way those applications actually get deployed, where they get deployed more and more, that's being determined by code as well. So it's not so much anymore that you go out and you just set up your infrastructure once and it's always there. More and more that infrastructure is determined by code as well. So in the container world, we look at things like Kubernetes, deployments in the YAML and Helm charts and things like that to go with it, but the infrastructure itself In a lot of cases, it's determined by something like a Terraform or other formats. And that's just code as well that can be scanned, and we can look for vulnerabilities there. The newest part of the Snyk family is actually the product that goes back to that core, that your own custom code called Snyk Code, which we announced back at SnykCon about a month and a half ago, I think it was. And so Snyk is really focused on protecting this entire application stack. So let's get into the container aspect of it here now. You know, we won't do a lot of container 101. This isn't really that whole sort of basics on what a container is or isn't, but I do want to focus on the security aspects of it. And again, one of the things that usually comes up when we talk about these things is, you know, comparing a container to a VM, because it's sort of the most natural and most direct comparison to look at those two things. You know, with VMs, I worked at VMware for several years, and we would have customers who would show us their virtual machines that have been running for a year or more, right? Maybe without a reboot at all. That's very common, right? These things are meant to last for a long period of time. As issues pop up, or, you know, patches need to be applied, you apply them directly to that virtual machine, but the virtual machine continues to exist you know, over time. And there's an expert who knows all the ins and outs of that virtual machine. They're a sysadmin type person. They know about operating systems. They know how to patch things. They know what's in the virtual machines, and you know, what to avoid, and all those kinds of things. Containers take on a very different sort of operational model, right? They're built for speed. So the idea on a container is we're going to strip out everything we don't need. There's a lot of shared components that we don't care about that you might have in a virtual machine that kind of exist outside the container. What we want inside the container is only the stuff, in an ideal world, only the stuff that our application really needs in order to function. And ideally, there's nothing else inside that container. So there's a lot of sort of that you know, desire to get this down to a minimal set of things. We also want to build on common things. We don't want to do this from scratch every single time. We want to have a common base that we can share so that people can do this rapidly. The great thing about containers is you can build on top of any existing container, right, and add more stuff to it. The problems there are you can be adding things on top of something that's already broken, and your own items, your own packages that you're adding to the container can also be broken. And so how you fix those things can be a challenge. And then on top of all that, we have this bonus challenge with containers in that not only do we have all these sort of intricate kind of problems, but the people that are there to fix those are maybe not operating system experts at all. They may not have had any virtual machine management experience in the past. They're developers, they're maintaining code and those kinds of things. So you start showing them operating system vulnerabilities, and they may not know exactly what to do. And because of the way containers are built, it's a challenge as well. It's not as simple as saying there's a vulnerability, it needs to be fixed. You can't always just patch it and have it fixed. That can break other things in the container if you do it that way. But the problem is a lot of security tools show exactly that kind of report. They'll show you all the vulnerabilities that exist in a container without the sort of details that a non-expert might need to go and fix these kinds of things, right? So going back to that race car analogy, right? We have the person who's designing the car. Instead of this dedicated pit crew that's all experts at exactly one function, we have this person who's the car designer, to use that analogy, and we're telling them, go be in the pit crew and start replacing parts. And here's the list of parts that need to be replaced. Good luck finding them and actually getting this done before the car can get back on the track. And so this is a challenge, right? We want to make this much simpler. That's the whole goal of Snyk Container, is to take this information and reorganize it into a way that a developer, an application team, can easily identify what's wrong with the container and how can it be fixed and make a better container for that application to run in. So, you know, the part of the intricacy here is realizing that a container is not like a VM. I can't just patch things, right? There are these layers in a container, and I may not own all of those layers. In fact, my company may not own all of those layers, right? We may get base images from somebody else, from Docker or from, you know, Red Hat or Bitnami or some other place, right? And then on top of those, we build our own internal things. And so identifying that and knowing how to fix those things is really an important part of this equation. Again, taking that whole list of vulnerabilities, first identifying, is this something I added or is it something that came in with a base image? That changes what I'm going to do next in terms of my fix steps. And so being able to identify that is part of it, but also being able to identify how these things are related, right? A vulnerability that comes up, and if you look at any of these things, you see a lot of little libraries and things like that. But I don't install all these individual libraries in my container, right? They come from somewhere else. I install a framework, or I install a particular development tool or package. It has interdependencies, and that's where these things come in. And so uncovering that data as well, so that, again, as a developer, I know, well, I installed this package, it introduced the vulnerability here, and I can easily decide how to go about fixing that. That's where we're really focused with Snyk Container. So we'll kind of take this in two steps as we look at what Snyk Container does, and we'll get into some demos here. We're going to start by looking at the base images, right? And how do we analyze the base image? How do we just help create and use better base images within our applications? And then we'll get into some of the user layer type stuff next. So this idea of picking a base image is a bit of an art, right? There's a bit of an art and a bit of a science to it. There's loads of best practices out there that'll tell you, you want to start with a slimmer base image, and that is partly due to security, right? The less stuff you have in a container, the less chance, the less surface area you have for a particular vulnerability or a particular attack to take place against that container. And so you can go out there and you can look through things like the Docker images, and you'll find, like in this example and the examples we're going to look at running in Snyk, are going to be Ruby based. It really doesn't make a difference which language you pick. It's the same idea here. You go and just look at Ruby as an image, Ruby latest to be more specific. It's a big image. It's 842 megabytes in size, loads of dependencies. And as of the time I did this testing, there were 9 high severity vulnerabilities against that image, and it'll change. Docker does a good job of maintaining those images, but so those numbers will go up and down. But the size, the relative size, the number of dependencies isn't going to change a whole lot, because what they do with the Ruby base image is they try and put everything in there to make any Ruby application easy to run in that image, which means there's probably a lot of stuff in there that you don't need, but there are a few things that you do, and they want to make this as broadly and easily usable for a broad audience as possible, and it does a good job of that. From a security perspective, that's not ideal. There's a lot of things in there that we don't need that could potentially be causing and showing up on vulnerability reports. It's a bigger, attack vector, and so the general guidance is we'll pick a slimmer image. Well, that's not always easy either, right? You can find things that are marked slim, and you can see smaller images out there in Docker Hub, but in reality, like just in this Ruby repository on Docker Hub, there are 700 images that exist. And so you can drill down and find specific Ruby versions, but you'll find things that are slim or alpine or buster slim or stretch slim and all these kinds of things. And again, if you're not an operating system expert, all of those words might not mean a whole lot to you. And so figuring out which image to use and which image to start from can be a bit of a challenge for folks. So we'll get into some demos here, and we'll see kind of how Snyk can help you with that. We'll start with looking at just the Docker file itself, right? So let's look at the Docker file, and we can determine what base image you're using. We can determine whether that base image is going to introduce a bunch of vulnerabilities or not, and help guide you there. Then next, we'll look at actually testing the full image. So we can test the Docker file with Snyk, and that, obviously without an image, we can only give you so much information because until the image is actually built, there's not a full, dependency tree that we can actually test. But we can tell you things from the Docker file. Then we can tell you more when we have the actual image, and we can actually link those two things together. So we'll look at that. And then of course you want to monitor images in a lot of cases as well. Running a test today is great. It'll tell you what's wrong with the container today, but tomorrow in the world of Linux, there could be a bunch of new vulnerabilities that pop up, and you want to keep an eye for those things and know that that's happening as well. So we'll take a look at these things here real quick. Let's switch over to my demo screen. So I've got several projects here. This is the Snyk interface. If you've never seen it before, I've got a bunch of projects that are in here. And essentially what I've done in this particular project, this blog project, is this is an integration with GitHub. So just straight from the code repository, I've integrated this. Obviously, there are loads of things that we'll find in this code repository. You can see, again, this is a Ruby project. So we've identified the gem file here. This is part of the Snyk open source product, right? Identifying the vulnerabilities that are in the dependencies for this application. Separate demo, we're not going to get into that today. What I do want to point out is the Docker file that's in here, right? So we can take a look at the Docker file. And again, we don't have the full image yet in this case, right? We have the Docker file itself. Now we can parse the Docker file and say this Docker file says that it's coming from Ruby 251, right? And then I add a bunch of stuff to that container. Well, we know what's in Ruby 251, and we can help guide a developer or an application team to a potentially better image to use from a security standpoint in this particular project. So we discovered that this one was Ruby 251. In Ruby 251, which is an old image, if you're not familiar with Ruby, 2.5 is a fairly old version, and 251 is a pretty old minor version as well. That I don't think is even maintained anymore. So there's a bunch of vulnerabilities in it, 900 vulnerabilities in that image, 250 almost high severity vulnerabilities. That's not ideal. And so what we do is provide pointers to some potentially better base images that this particular application team could use. So we categorize them. Here's a minor upgrade. We could go to Ruby 2.5 from that same repository, it's a more recently maintained image, so there's far fewer vulnerabilities in there. We get down to 33 high severity vulnerabilities. Or we also provide these alternatives where we get to things like Ruby 2.5 Slim. In that case, there's only 55 vulnerabilities, and again, we've cut down the number of high severity vulnerabilities. These are very simple changes to make. Obviously, you can change one line of a Docker file. If you're familiar with Snyk and Snyk open source, what we would do in this instance is we would open a fix PR, right? So we can go and say, well, this is the Docker file, this is the line in the Docker file, we know how to change that. And since we're integrated with GitHub anyway, or Bitbucket or GitLab or whatever it is that you might use, Azure repos, et cetera, right? We can open a fix PR and make this change for you. And that's something that we would like to do in the future with Snyk Container as well. But today we give you this recommendation so we can guide you towards a better base image. If you want to get into all the details, of course, you can see them all in this report as well, so you can dive into all the details. And a lot of times with base images, the details are not something that in particular a developer might want to dive into. They might just want to get to the point where, look, I've got 916, going to Ruby 2.5 Slim gets me to 55, and I'm good to go there. We see also a lot of use cases where customers will have, they'll have sort of a staged environment. So there'll be a team that will build an internal Ruby base image that they want their application teams to use. That team would probably see this interface, right? They're the ones that are going to pull things down from Docker Hub and make a determination about what the best base images are to use. They'll add, common tools that everybody in the organization is likely using to those things, and so they can really kind of customize that. And then the individual application teams will build on top of those. And I'll show you what some of the interface bits look like that help with that kind of workflow as well. But anyway, that's the Docker file scanning. The other bits that we talked about is actually doing a scan directly on the full image. There's loads of ways we can do this. I've run one here on the command line just directly. And so you can see what I did was a Snyk container test. Let me make this a little bit bigger so it's easier to see. So I did a Snyk container test on an image, right? And I also used the Docker file with this image as well. And that helps us with a couple of things. So we scan the image, we've got the list of vulnerabilities that we find in the image. Those are things that you probably would expect to see here, right? And some severity information, high, medium, low, etc. We also have base image recommendations here. So that same sort of thing that we saw in the Snyk interface, we provide here. In this case, it's coming from the actual image itself. So this is the current view of that image and the real information about what's in the base image, as opposed to kind of the inferred information that you would have if you only scanned Docker file. But again, we can provide like, the minor upgrades, just like we saw before. We have the alternative upgrades here as well. So again, suggestions on where to go. We also see, as you look at some of these vulnerabilities here, we can identify where this vulnerability comes up. So this one is, and most of the ones that we're seeing here were introduced in that base image. If we scroll up, you'll see some, like here, for instance, that were introduced by a different command, right? These aren't coming from the base image. This is actually coming from something that I installed. And we'll get more into that here in just a second. Now, the other thing we said we might want to do, that's a test, right? This is a test from the CLI. This is just me running it locally, which is something that a developer could do. If you're using Docker Desktop, you could do this exact same sort of thing with a Docker scan instead of a Snyk container test. So if you have teams that use Docker Desktop instead, it's an easy way to kind of get this testing thing there. That Docker scan is powered by this exact same command. It's a Snyk container test under the hood. If you wanted to monitor this thing over time, you could just change this to a Snyk container monitor, and all the other options still exist there. And what that does is it sends it over to Snyk. So we do actually, in fact, monitor that image, and that would pop up. You can see it here. For instance, actually, it's this that we scanned from the command line. But by doing so, what I've done is I've set this up to be rescanned every day. So if there's a new vulnerability tomorrow, I'll be alerted to that, and I know that I need to go and make some more adjustments and fix my container image. So that's what a monitor does as opposed to a test. So you can do those kinds of things as well. As you can see here, I can also integrate this with registry. So I've got an integration here with Docker Hub. I can integrate with ECR, ACR, GCR, all the big kind of popular container registries as well. So if you want to scan at that point, you can certainly do so. All right. So that's a lot on the base image, right? And so we'll provide those recommendations, help people get to a better base image on what to build and what to use to build their containers upon. One question that does come up for folks that are using other tools, right? So not everything is Docker. You can build containers in loads of other ways, and some folks are doing cloud native build packs, or they're doing Gib, or they've got Red Hat tools or things like that, right? There may not be a Docker engine, there may not be a Docker file at all. The container build may be part of some other application build, and that's fine as long as they're producing an OCI image. It's not a problem. We can still test those with Snyk container. We still report on the vulnerabilities, and we can support a broad set of pretty much any container image that you want to test as well. So all of those things work just fine. All right, so that's a lot on the base image. Let's talk for a second. Actually, let me pause for 1 second just to see if, let me just see if there's any other, I don't see any questions, but let me check one thing here real quick. Nope, I don't see any. Okay, so again, if you have questions along the way, feel free to type them into the Q&A panel. So let's talk about the other container images issues, right? So we talked about the base image itself and how we can help identify those issues and get to a better base image for folks to use. Let's talk about the issues you might add to a container, or your development teams might add to a container in sort of the other layers. So a big part of dealing with these issues in a container is prioritization, deciding what to fix, right, and what to focus on. There could be loads of things that come up in containers, and trying to deal with them all at once is a bit of an overwhelming task, particularly as we kind of think back to the audience here, right? Thinking about developers and those types of folks who may not have a lot of experience here. They don't have a lot of time, and for sure, to deal with this and to do a lot of research on all these vulnerabilities and figure out what they are. So a lot of the initial work is on just figuring out what to fix there. And a process for this isn't the only process. There are loads of other ways you could potentially do this. But a lot of times people want to look at, let's focus on things like high severity vulnerabilities. Does it have an exploit that's available, right? Those two things are big signals for things that I want to focus on fixing. If it's running in my Kubernetes cluster, then that's another big signal, right? So now I've got a high severity with a vulnerability, with a high severity vulnerability with an exploit that's running in production somewhere. And those are the things that I really want to focus on in the immediate short term, right? Those are things that we can't allow into the production environment. From there, once you get a hang of that and you get a good process for that, people will sort of expand it. Okay, let's look at things that aren't running in production that have an exploit. Let's look at, and we'll kind of lower the bar in terms of severity and things that we want people to fix. But, generally speaking, people come up with, with this list of things that they want their application teams to focus on. We make all these things available in Snyk so that you can use them to dig through these details and really sort of filter down to just those things that you want to focus on. So one part we talked about, and I'll show you this in the interface as well, right, is being able to determine whether something comes from the base image or it's something you added. That's two different fixed processes. And in a lot of places we talk to, the developer teams don't even care about what's in the base image because it's a different team that manages the base image. That team has to worry very much about that, but the developers don't even really want to see those issues because they're not something for them to deal with. They've been told to trust the base image and somebody else will deal with that issue. So we can separate those things out. Also, making it very easy and obvious for that developer to figure out exactly what the issue is and exactly where it comes from. So we'll show you the Docker file instruction that introduced a vulnerability, so you know exactly what you put in the Docker file. But we'll also show you that dependency tree, right? If it's a library that's a part of something that you installed, it's a bit esoteric, but if you can link it back to the actual package you installed, then you have a good idea of what needs to get fixed, as opposed to some weird library that you may not know how to deal with, right? So we make those things very easy. Of course, you can look at things like high severity, you can look at things like exploit maturity, you can look at whether it's running in the Kubernetes cluster. All of those things are exposed in the Snyk interface as well, in ways that you can slice and dice the information to help those application teams focus on the things that are the most important to deal with. All that goes into prioritization. Prioritization really is a bigger thing than Snyk Container. It's part of the entire Snyk platform. So whether you're dealing with the code or you're dealing with a container issue or you're dealing with an infrastructure as code issue, prioritization is a big part of what Snyk does. So we don't just look at the fact that it's running in a Kubernetes cluster, for instance. We can look at some of the configuration for that pod, for that container in the Kubernetes cluster and say, not only is this running in production, but it could be running as root. There's no CPU limits or memory limits, right? And given this particular type of vulnerability, it could have a bigger impact if it's exploited, right? And so that would raise the priority score we add. So, that's something that we expose in the Snyk interface to you as well. I'll come back to where we test here in just a second. So let's take a look at some of these items in Snyk, so that you can see how this works as well. Let's look at, I'll look at this image. So again, this is our blog image. You see the same thing that we saw before. When we were just looking at the Docker file, we saw the base image upgrades. We see the same base image upgrades here, even though this is the full image in this case. So those two things are very much interrelated, and you can tie those things together actually in the Snyk interface. Here. So that's the same, but what we have down here below is the ability to start getting into the data about this particular image and some of the details and how we might want to deal with these things. So again, if I want to ignore all the base image or skip through all the base image vulnerabilities, I can turn that off and I can see only the vulnerabilities that are coming from other places in that Docker file, right? Other layers of the container image itself. So this gives me the actual command that was used to install something that introduced vulnerabilities, this particular vulnerability into my container. And I can see the path here as well for that vulnerability. So I installed Git and Vim here. I can see that Git in this case was one of the things that caused this vulnerability to appear in my container. So I know that this particular line, it's this Git package that actually introduced this vulnerability. Now, vulnerabilities in a container, again, in the Linux world, there's loads of things that could be dependent on the same library file. So we see other paths to that vulnerability as well. If you want to get more details about that, like there was a curl dependency here, and I don't have I didn't even know curl was in here, you can actually see those details through the dependency tree. And this is in the UI. I know that there's a lot of developers who may never log into this UI. You can see these same details from the CLI as well. So if you want to get this dependency tree output, you definitely can. But the information about how this was introduced, we saw in the CLI commands here, we saw the introduced by, and we saw the introduced by the Docker run command. So we can definitely see those things in the CLI and in other places as well. But anyway, if you want to go through these dependencies, you definitely can. So here's curl. I can see that curl is where curl came from. It's part of the base image in this case. And I can see all the other packages that are part of this container image as well. And I can see either all of them. These are just the vulnerable vulnerable packages, but I can get through all the dependencies if I really want to get into the details of what's in this container and make some more sophisticated determinations about what should and shouldn't be in this this container at the end of the day, right? In this particular container, for instance, just looking at the first few lines, I have apt in here. Now, apt is a way to install packages into the container. If I'm a developer and I'm testing things and I'm need to add more packages to this container or remove packages from the container, I'm going to need apt. That's what I use to do it. The final image, the one you run in production, you're using multi-stage builds, whether they're distinct stages of builds that you use throughout your sort of life cycle, or it's like a Docker file multi-stage build, either one. You may not want apt in your final image because you may not want people installing new things into your production images, right? So you would take apt, you either take apt out or find an image that doesn't have apt in it and build upon that. Same with things like bash, which would be a shell, or curl, right? And some of these other tools that would be in there. So you can see all that information in this Snyk interface. You can also come in and we can filter by severity, obviously. You can see exploit maturity details. So if I want to see only exploits, only vulnerabilities that have an actual exploit that's in the wild, I can do that and see that information here. Again, all of that affects this priority score as well. So the priority score works along with the severity and the exploit maturity and whether this is running in Kubernetes or not, right? And is reflected in this overall vulnerability score. So that's a way you can kind of rank things overall. Speaking of Kubernetes, we'll look at one that's actually scanned from a running application. So I have this same container, right? Running this time in a Kubernetes. It's not really a true cluster. It's running through Docker Desktop, so it's just a single node, but it's running in Kubernetes nonetheless here on my desktop. And so I've got the same information, right? The vulnerability details are basically the same, but because it's running in Kubernetes, I have some additional details. So I have the configuration, some of the configuration details for that pod here as well. And so I can use this information to also influence this priority score. So again, more than just the severity or the availability of a fix or the availability of an exploit, we're also looking at the running configuration here. So you can see that all that comes into this priority score. In this case, it's high severity, there's a fix available, and the way it's configured to run in the cluster opens me up to all sorts of other bad potential outcomes. And so the priority gets raised due to all of those things. But that information is available in here. We also have, and we're not going to get into it today in any real detail, but we have a Snyk infrastructure as code, which I mentioned kind of early on. And that's designed to actually get to this and fix these issues for you, right? So showing in the actual deployment file, which again, in this case, I just picked up from as part of this repository, right? But in this deployment file, I can look at the actual configuration for this pod. And Snyk infrastructure as code would help me create a better deployment. Same thing, you see Terraform here, we do the same thing for the infrastructure. So again, we're not gonna get into the details of all that today, but you can see those things there. Some other interesting things to look at as you're thinking about container images. I've only got a handful of images here. You're gonna have a ton that you're potentially scanning here. And there's other ways to analyze and sort of filter in terms of whether you want to deal with a container vulnerability or not. In this case, I've used some of these other attributes that you can apply through Snyk to determine and set some details about this container image. So this is in the development lifecycle. I might be less restrictive about the packages and the vulnerabilities that are here. apt and git and vim and all those other things that I installed in this particular container, I might not care about since it's a development stage container. People are still testing things and playing with them. I still want to flag them so people know we don't want these in our production environment, right? If this were a production image, I probably would want all those things, or at least a lot of those things, to be gone. So we can use this to help filter and view those vulnerabilities and provide some perspective on how we might want to deal with those vulnerabilities as well. Okay, so some other things we can do. That's all looking at the container images, right? So we looked at scanning container images locally just on the CLI. We looked at scanning and how we might break apart those container, the vulnerabilities and figure out how to deal with them, whether they're in the base image or they're somewhere else in the container, and how we can kind of filter that and apply a number of different lenses on that to prioritize what an application team should focus on. Instead of the grand universe of 700 vulnerabilities, let's try and get that down to a number that's reasonable to deal with quickly and easily, that also adds a lot in terms of risk reduction in the overall environment. So we've looked at those things, but there are a number of places where you might want this testing to happen beyond just importing an image or connecting it to your registry. Most people are testing their container images as they build them, right? So they're doing that in CI, and Snyk can work with your choice of CI tools to do testing. This is a screenshot from Circle CI, so we work just fine there. We work with, generally speaking, any CI tool that you might have. And so we can apply that. As you notice here, some different things that I've done in this particular test. So I've set a severity threshold of medium. So I don't care about every vulnerability that appears in this container. I'm only going to focus on medium. You could set it to high or something else if you wanted to as well. So I'm filtering this with the developer. If this fails the build, right, there's only a handful of things I want them to be focused on, or a handful of reasons why I want this to particularly fail a build. If I choose to fail a build, which is an option that you have. I've also excluded the base image vulnerabilities from this report. So the scan will occur, but it's not going to show all the base image vulnerabilities. It's only going to show the user layer vulnerabilities in that final report. I still get the base image recommendations, right? Because it's still part of it, but I don't get that full list of all the other vulnerabilities that are there. We can send this off for monitoring. You can do all the other things you might want to do with Snyk Container. You could also test the code here as well. As you mentioned, right, Snyk does a number of things. So we could test the code, we could test the container, we could test the deployment files and everything else as part of this process if we wanted to do that. An interesting integration that we just released not too long ago via GitHub is the ability to do all of this in GitHub's interface. So if you're using GitHub and you're using GitHub Actions and GitHub Security, you have the ability to take this information and put it all into the GitHub Security tab. So again, as a developer, if GitHub is a tool that I use every day, I may want to just see the output in GitHub, right? I don't want to go to a different tool somewhere else and see those results. The same information is available, but we're just displaying it in a different place where again, it might be more familiar, it might be more to the developer's liking to have it appear in GitHub rather than logging in somewhere else or doing a separate test. And then we talked about being able to go through some of these environment specifics and looking at the various packages and things that might be in a container. And being able to solve for those as well, and use that as a lens on how we prioritize. So we already saw that in the demo. All right, that's the demonstration for today. So again, I hope this kind of helped clarify what we mean by developer first container security, and helped to show a little bit of what we do that we think is different from other image scanning tools. There's loads of image scanning tools out there, but I think our unique take on it is the focus on providing information to the developers, right? There's loads of tools that are used as a sort of a gate for security on whether we're going to allow something into production, and that's certainly an important step in the overall process. But when something doesn't get through that gate, it's up to the developers and application teams, and a lot of times, to go and fix it. And that takes more than just knowing how many vulnerabilities are in the container. it requires some additional steps there, right? Again, think back to the car. We've got our car designers who are now out in on pit row, and they're the ones that have to replace the tires on a racetrack and get us back out and running as fast as possible. We can't just give them a wrench and tell them to go fix a tire, right? We need to give them more details on how to do that and make it happen fast. And so that's where we've really focused with Snyk. If there's any other questions, I'm happy to take them now. I don't see any in the panel, but if you have any, feel free to type them in. And if not, we will wrap up for the day. I don't see anything coming in. So I appreciate everybody coming and joining us today. As I said, this will be available, the recording, this will be available if you want to rewatch or if you want to share with others. And if you have any other questions, we'd love to hear from you and love to have you to reach out to us. If you want to see a more detailed demo, if you want to go through your particular environment, what the tools that you use, how you build containers, your CI tools and process, and relate that to how Snyk Container might work, we'd love to set up that sort of custom demo for you as well. So again, thank you for joining us today and enjoy the rest of your week. Thanks.